Hello students, how are you all? The new variant of corona, Omicron, is now in full swing. The third wave has begun. So I thought I will shoot some videos and teach you some lessons. And this time I am starting with class 11th and volume 2nd, and the chapter I have chosen is properties of fluids. Before we study about the properties of fluids, first let us see how do we categorize matter. Matter is divided into three parts, we say, based on their characteristics. One is matter is made up of solids, it can be, or it can be liquids, or it can be gases. So these are the three broad categories in which matter is divided. So each one has a different property. When you take a solid, for example, this duster is made up of wood and wooden particles, wooden atoms, wooden molecules, and it has a definite shape and definite size. Now, you will find that in solids, the molecules are closely packed. Okay, so they are all closely packed, so they cannot move totally out of this object. The molecule cannot move out of the object, but they all vibrates in its own position, and there is a vibrational energy. Okay, that's a small movement of them, and it is having its own place, it cannot move further than that. Now when you come to liquids, again, for example, if I take a glass of water, right, I take a glass of water. Water is a liquid, right, and here the molecules are not so tightly packed. Okay, now let us see how it is. They are little loosely packed. You know, water is nothing but H2O, molecules of oxygen with the two hydrogen, right? The molecules are not so tightly packed, so they have the benefit of moving here and there. What happens actually because of that? It does not have its own shape. Size is same, but it takes the shape of the vessel or the container in which it is being put. Suppose if I have a pot and if I pour this water into this, it will fill like this and the molecules will be here, and the shape of this will be that of this shape now. Yes, and if I suppose I put it in a beaker, again you see it is going to be something like this. We don't know, depending on how much volume is, and that it will occupy this much like that. So it does not have definite shape. The shape depends on the container or the vessel in which it is placed. Now come to the third state of matter, gases. Now gases, I have in this room gas, right? Hydrogen, oxygen, carbon dioxide, maybe so many other gases are there, and there they are totally free to move. Even let me draw this room like this, right? There's a volume here, and the gas molecules are free to move. They are free to move. So this is the main difference between solids, liquids and gases. That is based on the molecules, how are they being in the particular matter. Now, when we talk about properties of matter, before we go into fluids. Now what is fluid now? Fluid is the common term for both liquids and gases. We call it as fluids. The word fluid means which can flow. You look there, for example, if I take water, the water I see it is able to flow. Water is able to flow. Gas can flow from one room to another room. Wind is flowing, right? Breeze is flowing, right? So you will find that the liquids and gases can flow, so they are generally called fluids. Now, again, before we go to only the properties of fluids, we should learn a bit about The properties of solids first of all, right? So basic properties, what are the things going to be? First, I'm not going into detail of it. I'm going to go to the mechanical properties which is being stated by Hooke's law. Now, what is this Hooke's law? What it says? It terms two terms it uses. One is stress and another is strain. So it says that stress is proportional to strain. Stress is proportional to strain. You may wonder, what is stress? You say, I have mental stress. Yes, it is also a type of similar thing. We are going to apply some external force on a body. For a simple example, let us take a rubber band. Okay, now let us say the length of the rubber band is L, and let me fix it here at this point here. Okay, now what I do, I am going to pull this rubber band. When I pull this rubber band, what will happen? It will stretch, it will elongate. When it elongates, what will happen? Its length is increasing. Okay, its length is increasing. Let us say the change in length is going to be delta L. So I apply the force here, right? And the force acting per unit area, the deforming force, the force which changes the shape of the body. And when I pull it like this, it is changing the shape. The moment I leave the deforming force, what will happen? It will go back to its original position. Now what I apply is the force, external force, a deforming force, and the body will go back, and that is because of restoring force. The restoring, and this is deforming force. Okay, so restoring force restores it back to its original position or shape, and that is called elasticity. And this is referred to as elasticity. Elastic properties. Okay. Now, the force acting per unit area, the restoring force, and that is called stress. So, what is the unit now? Newton per meter square. It is nothing but pressure. It is similar to that of the pressure. Okay. Now, that is one part of it. And now, what is strain? Because I applied the stress, there is a strain, and that strain is here longitudinal in nature. Longitudinal in nature. So what is happening? Change in length upon original length. It can be linear, only length can change, or it can be longitudinal, length and breadth can change, and that is called longitudinal strain, and this is referred to as longitudinal stress. You can call it as longitudinal stress. So, who suggested stress is proportional to strain? More the deforming force, more the strain or change in the length with respect to the original length. So, we can say that stress is equal to, here it is proportional. We don't know when one rises, the other will rise by how many times. It is only proportional. They are directly proportional. But we bring a constant to make it equal, and that constant we will define now and is equal to strain. Or generally we can say stress upon strain is equal to the constant. And this constant is called generally modulus of elasticity. Modulus of elasticity. We are studying about elastic properties, the mechanical property. Again, I have not come into fluids. I am only discussing about solids. Okay, then I will shift to fluids. So, what is this now? Stress upon strain. We know stress upon strain is a constant, and I call it as modulus of elasticity, and here it is longitudinal stress upon longitudinal strain. Both are lengthwise or breadthwise. So that is called a constant, and that modulus of elasticity is called Young's modulus. Young's modulus. Okay, we call it as Y. Okay, y is equal to f upon a divided by change in length upon original length, that is f upon a into L upon delta L. Okay, so this is a basic concept about the longitudinal stress and strain. You may wonder, should the change be only with respect to length and breadth? No, volume also can change. When the volume changes, it is called, you can here change it here, volumetric stress upon volumetric strain. When volume is changing, what is going to happen? For example, let me erase this part of it and take the next example. Let me read the longitudinal part of it. Okay? Because now the next factor which is going to change is going to be the volume. Okay? Volume. What is volume? Space occupied by the body, right? And there is going to be change in the space occupied. Let me take a ball, right? I have taken a spherical ball. Now what I am going to do, it is having a volume V initially. I apply a force here, deforming force over a given area, and I apply another force here.